Josh, you getting ready for a good weekend?
Yes.
I get to go up north tomorrow, so I'm excited about that. Some sort of festival. So we are looking at lecture 24. Lecture 24. Lecture 24 will take us a while. We finished 23 dealing with angle measures and all those. We're going to be dealing mostly with radians today. Okay, I'm not going to be dealing with degrees. We'll put them in on the unit circle to help you kind of make the connection, but unit 24, or lecture 24 is right triangle trig. And then of course, we're going to deal with some trig functions. And of course, the unit circle. Kind of introduce you to the unit circle and how we're going to use that throughout the year. So number one, let's do some basics. You have it there in front of you. Let's do, I guess we should do Roman numeral 1. Let's do the beginning again. Roman numeral 1. And let's talk about the unit circle real quick. There are 3 things we need to know about the unit circle, 3 characteristics. Number 1, the radius equals, look at it and tell me what the radius equals. Can you tell?
Pi.
Say it again.
Pi.
Pi. Good guess, no.
3.
What'd you say? 3? No.
Are we not told?
2 pi.
No.
Pi to the x.
Are we
squared
supposed to
over
know?
Well, it does say the unit circle.
1.
1.
6.
Radius is 1. Letter B. So the radius is 1. Number 2, the center is where? This one you should know and be able to
0,
tell.
0.
It's the origin, 0, 0. Okay. And then letter C, I'm teaching this in college algebra. I don't think we had it last year in algebra 2, I don't think we got that far. Some of you may have seen it before, but the equation of a circle. Okay, so the equation of the unit circle is x squared plus y squared equals 1. So x squared plus y squared equals 1 is the equation for a unit circle. All right, now, I don't think I need this one. This one, we'll come back to that. So unit circle, 3 things. You see one in front of you. You see a bunch of lines on it, different places. Hopefully it'll all make sense before we're done today. At least the first quadrant, okay? So Roman numeral 2. We need to go back, and this is a little bit of review. We need to go back and look at trig functions. So we've been talking about linear, quadratic, exponential, absolute value, cubed root, all those different types of functions, parent functions. We need to talk about trig now, sine, cosine, and tangent functions, and then of course the other 3 as well. So let's talk about them real quick. We know the trig functions, sine, right? Okay, it's abbreviated SIN. We don't ever call it sin, right?
Why?
Because we don't. It's sine.
Where's the
Okay. Sine. Now, I'm going to do 2 in 1. Yesterday we did this in 2 different parts. I was thinking it's kind of a waste of time, so I'm kind of saving a little time. So we're going to use the Greek letter theta to represent an angle. So just get used to the idea of theta. Theta is like a 0 with a line through it, theta. So the sine of theta, go back to your geometry teachings and what ratio is the sine? It's what divided by what?
Opposite over hypotenuse.
Opposite over hypotenuse. Now, what do we mean when we talk about opposite and hypotenuse? What's that referring to?
Opposite angle of the right thing.
So it has to be a right triangle, correct?
Correct.
So we look at a right triangle. We look at a right triangle, and wherever theta is, this would be the opposite side, right?
Yeah.
This would be the adjacent side.
Yeah.
This would be the hypotenuse. Doesn't matter what the size of the sides are, they're always in the same proportion. The opposite divided by the hypotenuse is always the same for a 30-degree angle, always. Okay? If the opposite of 1, the hypotenuse is 2. If the opposite is 10, the hypotenuse is 20. It's always a 1 to 2 ratio. Okay? If the opposite is 50, the hypotenuse is 100. Okay? It's true for, it doesn't matter what size it is, and a 30-degree angle. True, the thing's going to be true for all the other trig functions. So it's opposite divided by hypotenuse. So letter B. We have cosine. And that's abbreviated COS, not cos, but cosine.
Oh.
Can anyone tell me what the cos stands for?
Oh.
Okay, so it definitely is the adjacent over the hypotenuse. But do you know what the co stands for? The CO, like we have sine and now we have cosine. Do you know what the co stands for?
Opposite.
Did you say the alphabet?
No.
What'd you say?
Opposite.
Opposite. Kind of. Not really. Sort of,
So,
but no.
along with it?
Cool.
It actually starts with the CO.
Oh.
When you were in geometry and you had two angles that if added together, yes.
Composite?
No. If you had two angles that when added together equaled 90 degrees, they were called what type of angle? Complementary. So co actually stands for complement. So cosine is the complement of sine. Okay? That's going to come back in a little bit. It's the complement of sine. Okay? And it's the adjacent of hypotenuse. Letter C. We should know the tangent. So tan, we don't say tan, we say tangent of theta equals what? I'm sorry? Opposite over the adjacent. In fact, you guys remember the old game Tetris, right?
Yeah.
So let's just say the H's completed a row so they fall away and then everything else just falls. Opposite over adjacent. All right, so we've had those trig functions, correct? You've seen those before?
Yep.
Fantastic, let's do the fourth one.
Oh, yeah.
Let's do these in red because some of you may not have seen this before. So let's go D. D is going to be called the cosecant. It's abbreviated CSC. So the cosecant of theta is going to be what?
It's, hypotenuse over opposite.
It is.
Yeah.
Hypotenuse over opposite because why?
Because it's the opposite of sine. It's like,
It's the reciprocal
yeah, reciprocal.
of sine. Very good. Very good. Letter E. Okay, so we had a sine and a cosine. If I tell you there's a cosecant, then there's also going to be a
Cosine and
secant.
secant.
And it's going to be abbreviated SEC. Some of you know that as a football conference. Some of you know it as a Security Exchange Commission. They deal with Wall Street and those things. We're going to call it the secant. And of course, what's secant going to be?
Hypotenuse over adjacent.
Hypotenuse over adjacent. Okay, very good. And that's going to be the reciprocal of B. Okay? And then F is going to be obviously what?
Okay.
Cotangent, because they all have a co, so we have cotangent. So we have every trig function and their complements.
Yay.
Okay? So we're going to abbreviate that as COT, not cot, but cotangent. And obviously that's going to be
Adjacent over opposite.
A over O.
A over O. Adjacent over opposite because it's the reciprocal of tangent. Outstanding. So we got the 6 trig functions. One of your assignments today is going to be find the 6 trig functions at a particular angle. So we'll show you how to do that. Okay, we got those? We're good with those? All right. Let's do something a little interesting. I actually should have given myself a little bit more room. This is where it's kind of an advantage. Whoops, back up. Let's see if I can do this real quick. Let's take all this and let's slide it this way.
It's moving it.
Shut up.
All right, there we go. And, all right, so then let's make a circle. So in your notes, make a circle. It needs to be perfect like mine.
Big circle.
I don't care, it needs to be perfect like mine. We're gonna make some notations in there. So make it as perfect as you can. One of these days, you too will learn how to draw a perfect circle, like me. I would like for you to go ahead and draw the X and Y axis in there. So X and Y axis. So we've got a little target. Now, for review, we do remember that over here is, let's just do for right now, let's do things in degrees. That'll make life a little bit easier. And then we'll transfer it to radians. Okay. So this one's going to be 0 degrees. Okay, what was up here? 90. Down here was 180. Down here was 270. Okay. So, and we hopefully remember the radians, 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So, let's go in here and let's make a line in the first quadrant. I don't care where you make it. I'm going to make mine kind of in the middle. But it doesn't really matter because it's going to be effective wherever the line is. Seriously, you could have drawn it here. You could have drawn it up here. You can make it wherever you want. Because we're going to do things in general terms. So we've got that line. We've created, we know standard position. So we know this is theta here. It's my central angle. Now what I'm going to do is I'm going to go ahead and create a triangle. So from this point, wherever it hits the line, I'm going to come straight in and make a right triangle. Okay, you got it? Give me a second to get that sketched. Got it? Let's put some labels in there. Okay, so let's do this in green. What's this distance here from this point here over to this mark, over to where it touches? What's that distance? And don't give me a number, give me a letter. Not A.
X.
What'd you say?
X.
X. Why is it X?
It's on the X.
It's on the X-axis? It's X. Exactly right. I need to somehow change this so it's always X. Okay, very good. Okay, so then if I go up here, what's that distance from the X-axis to that point?
Wow.
Okay, last one. What's the distance from the origin along this hypotenuse?
H.
Oh, it's
No. What's that? C? No.
Y.
D?
Q.
F?
Z.
What are you saying?
C.
C as in cat?
Like the last letter of the alphabet.
Z as in zebra.
Yeah.
Why did you just say that to begin with?
I did.
Okay, Z. No, it's not Z.
It's
Q, Y.
X.
It's not 2Y.
Do it.
That's
X
it.
over Y. Y over X.
What are we doing
Plus
again?
Y
Coming back
squared.
to you. You got the right answer.
Is it
1.
Third of X squared plus Y squared.
Square root of 2.
No.
Oh, wait.
Y over X?
The 1?
Okay, so we're going to tie it to 1 in a bit. Okay, but for right now, think about it. I'll give you a hint. Look at it in a different way. It goes from the center to the circle.
R. 1.
If you said that earlier, I apologize. Once again, I am deaf, but it is when we use R. Okay, so the sine of theta, while it equals the opposite of the hypotenuse, what is that in terms of this particular triangle?
Y over R.
Sorry?
Y over R.
Opposite is y, h is r, so y over r. Now, in a unit circle, we know that r is what?
1.
1. So then the sine of theta is going to be the same thing as y. Okay. Do you see on your unit circles? Out here there's an ordered pair.
Yeah.
The y is going to be what?
1.
The y is going to be what?
Sine.
The sine of whatever that angle is. As on the cosine. What's the relationship of cosine?
Adjacent over abundance, so it's
X over R.
X over r.
Yeah.
We know that r in a unit circle is 1, so x over 1. So we know that x is going to be the cosine. So in our ordered pairs, the x is the cosine, the y is the sine.
What's the tangent?
Great question. What is the tangent? Opposite over adjacent, what is it?
Y over X.
Y over X. Now, we have a problem with that, because we just got done talking about rational functions, okay? And if I have Y over X, what's my domain restriction? Just took a test over it.
What makes X equal 0?
X cannot be 0. See, with sine and cosine, there's no limitations, they can do whatever they want. But with tangent, since it's Y over X, X can be everything except for 0. Now, where is X 0 at? Tell me the degrees.
90, or 0, 90.
So 90 degrees. Where else is the 0 at? 270. So if you put in your calculator, what is the tangent of 90? It's going to have to divide by 0. It's not going to be able to do it. So tangent of 90 is undefined. Tangent of 270 is undefined. Because you can't divide. And any up and down, the tangent's going to be undefined. Okay, let's go with cosecant. What's the cosecant?
R
R
over.
over Y.
R over Y. In a unit circle, it's 1 over Y, which, well, not equal to. What's going to be true at this point?
Y can be 0.
Y cannot be 0. So the cosecant has issues when Y is 0, which is going to be at 0 and 180. This is where Y is 0. All right, what about secant?
R over X.
R over X. You know where we're going with this? And you just circle the radius is 1. X cannot be 0. So secant has the same problems the tangent has. Okay? And then cotangent is going to be
X over Y.
which simply Y cannot be 0. Which is one reason why, which is one reason why on a unit circle we only put the sines and cosines. We can calculate the rest of it. That's why on here there's an ordered pair that'll be your sine and cosine of every one of those values. All right, so we got sine, cosine, tangent. We got the. Any questions so far? Are we moving along pretty good? Does it make sense? All right. If you have questions, please stop. Let's take a look then at the first quadrant of a unit circle. Let's see here. How am I going to do this? Plus, let's look at. You should have a unit circle in front of you. Like this.
Yeah.
Now, I kind of need two of them. So let's make another one.
How do you do that?
Sorry, I should have been a little proactive and had this done already. I apologize. There we go. And we want just the first quadrant, so I'm going to go from about the center out. About the center out. Okay. Now, how many of you remember, I think I asked Lachlan this morning, how many of you remember your special triangles? Your 30, 60, 90, and your 45, 45, 90 triangles. Do you remember those?
Scaling bases, equilateral.
Do you remember 30, 60, 90? Because you did them in physics last year, right? Or whatever class you took. Engineering. So you did them in engineering last year?
They're in it right now.
Oh, you're in engineering, you guys are in engineering right now? So you'll be doing 30, 60, 90, 45, 45, 90 triangles. All right, bud.
I'm an engineer.
So. Oh, that smells good.
Is it food?
Okay, so, let's take a look. Where do we start with this one? I always question myself when I get ready to start doing this. So let's go back. You have the unit circle in front of you. We know that this one here is going to be 0 degrees, which we know is going to be 0 radians. Now, someone asked me, I don't know if it was in this class or not, when we have degrees, we put the little degree sign. Radians don't have a unit of measure. Don't put anything with it. It's just a number. It's just pi over 2 or pi over 3, 0. We don't put any unit with it. Okay? So it's just 0. Now, what is this ordered pair right here?
0, comma 180.
Zero, one.
180.
The ordered pair.
0, 1. 1 0. 1 0.
Zero.
1 0.
1.
0. Now, if you want to check me, okay, remember what was the x value? X value is the sine or cosine.
That is the cosine.
The x value is the
Cosine.
cosine. So if you want to check me, the cosine of 0 in your calculator, it will equal 1. Okay? What's the y value?
0.
The sine.
Oh.
So the sine of 0 is going to be
0.
0. Okay? Because we have, at this point, we have angle 0, 0 degrees, 0 radians. The cosine is 1, the sine is going to be 0. Okay? So the next one up,
30.
we're going to do is going to be 30 degrees. Okay? What is that in radians? What's 30 degrees in radians? 3?
5 over 6.
What'd you say?
5 over 6.
5 or 6?
Yeah.
Okay, so let's go back to and use our brains from way back when. And we have a 30-degree angle. I drew a little shallow there, sorry. 30-degree angle. What are the side lengths of a 30-degree angle? Does anyone remember?
36 net.
36 to 90. What are they? Across from 30 is
60. 60.
1. So the hypotenuse would be
2.
2. And the other side is
3.
radical 3. 1, 2, radical 3. Did you say 3?
Yeah.
It's not 3. It's radical.
Well, it just made sense.
It's 1, 2, radical 3. Okay. So, what is the sine of 30 degrees? Sine of 30 degrees equals what? 1 over 2. Boom. The sine is 1 over 2. What's the cosine of 30 degrees?
Radical 3 over 2.
Square root of 3 over 2. So, radical 3 over 2.
So it's always going to be the sine and the cosine for the ordered pair?
Order pair.
Okay.
Cosine, sine. They go in alphabetical order. Cosine, sine. Now from that we can develop, like I could ask you, okay, what's the cosecant? Well, cosecant is the reciprocal of which function, sine or cosine? The cosecant.
Sine.
It's reciprocal of sine. So if sine is 1/2, the cosecant will be
2 over 1.
2 over 1 or just 2. So I can develop all the rest of them. We can come up with sine. We can come up with tangent, cotangent as well. Okay, now this is what's interesting. Okay, let's go back to this one. All right, let's use the same triangle. And let's do, okay, what about 60? Because right here is a 60-degree angle, which is going to be what in radians?
60 pi over
What'd you say?
Pi over 3.
Pi over 3.
Yeah.
Because it's twice as big. So it's pi over 3. Now remember, what does the co mean?
Complementary.
Complementary. Okay, let's see if we can make a connection. What is the sine of 60? So we have a 60-degree angle. What's the sine? What,
Radical. Yeah.
square root of 3 over 2, right?
Yeah.
So the sine of 60 is the square root of 3 over 2, which happens to be the cosine of 30.
Cool.
What is the cosine of 60 degrees?
1 over 10.
Adjacent over hypotenuse, 1 over 2, which happens to be the sine of 30. That switch places.
Okay.
Okay? Sine, that's what complement means. 30 degrees, the cosine means the sine of its complement, the sine of 60. The cosine of 60, okay, means the sine of its complement, the sine of the 30. So they switch cosine and sine, switch places. Questions so far, does that make sense? I'd rather you understand this conceptually than just memorize a bunch of numbers on a chart. Does that make sense?
Why is it pi over 6?
For the angle?
Yeah.
That goes back to our conversions. I have 30 degrees, so I'm going to multiply by pi over 180. That's my conversions we did the other day. So then it's 30 pi over 180, and that just reduces to pi over 6.
I don't get it conceptually.
Is it always pi over 180? And you just plug any number in there?
Going from degrees to radians, yes. Going the other way, you would multiply by 180 over pi. You'd flip it.
Okay.
Yep. Yeah, we did that the other day. I don't know if you were here. You may have been absent the day we did that, because we just did it Tuesday.
Oh, yeah, no, I was gone on a field trip.
Yeah, you were on the field trip. So we just did that. I can show you the notes. Okay. All right. You don't get it conceptually. What do you not get?
Why?
Because of my 3069 triangle.
Okay.
I mean, it really, if you can't remember that part, it all goes back to that triangle. Okay. What is the sine the sine of 30 degrees will always be 1/2. The cosine of 30 will always be square root of 3 over 2. Since they're complements, the sine and cosine switch places.
I have one question.
Yes.
Why is the outer side lengths 1, 2, and square root of 3?
One, what?
Why are the outside side lengths 1, 2, and square root of 3?
Over here?
Yeah.
Okay, so, once again, you should have been taught this in geometry, you probably don't remember it, but that's okay. So what we did was we did a 30, 60, 90, and we said the smallest side is 1, okay? So if the smallest side is 1, what are the rest of them? Okay? And there's a long way of solving them. This is kind of like the, I don't know how to explain it. How do I explain this? I know Pythagoras' theorem, the square root of 3 squared plus 1 squared equals 2 squared.
Cool.
Square root of 3 squared is 3, 1 squared is 1, equals 2 squared, which is 4. So I know it checks with Pythagoras' theorem.
Okay.
It's kind of like a, I don't want to say a pair function, but it's kind of like a basic, this is kind of the building block. We start with this, then we can make other triangles from it.
I still don't get why it's 1, 2, and radical 3.
Can you just accept for me right now it is?
Yeah.
Okay, just accept for now, and I'll try to explain it to you later. Okay,
Okay.
all right. This is gonna blow you away, because I'm gonna do a 45, 45, 90 triangle next. I'm gonna tell you what those sides are. But
Okay.
I can explain that one pretty quickly now. Okay. All right, other questions, or can we go on? We getting the idea? Okay, so then, let's do, this middle one. Let's go back here, I should have started here, and let's go this middle one, we'll call it 45. Okay, what is 45 degrees in radians?
Pi over 5.
Pi over 4.5.
Yeah, so you take 45 times pi over 180, and you get pi over 4. So pi over 4. Okay, so let's go back to my special triangle. And this is actually going to be a 45, 45, 90. Now, my special triangle is 45 degrees.
That's so cool.
What do I know about the opposite and the adjacent in a 45, 45, 90?
It'll be the same.
They're going to be identical. Whatever one is, the other one's the same. So because this is a triangle, I'm just going to call this, forget about the unit circle, I'm just going to call this 1. Therefore, this is going to be 1, 1 and 1. If this was 7, this would be 7. If this was 43, this would be 40, they would be identical. Okay? Then what's the hypotenuse?
2 times the amount of the opposite.
So just 2.
Close, but then you have to do what to it? You have to take the radical.
Square
So it's
root of
actually
2.
square root 2. Because if you did Pythagoras' theorem, 1 squared plus 1 squared equals c squared, 1 plus 1 equals c squared equals 2, so c equals radical 2 if you do the Pythagorean theorem.
Cool.
Okay?
That makes sense.
So, do you guys remember solving angles like this? Like,
No.
let's just say, hypothetically, we had a right isosceles triangle, which is a 45, 45, 90, let's just say this was 30. What length would this be? 30, what length would this be? 30 times radical 2. It's 30 radical 2. If this was 110, this one would be 110, this would be 110 radical 2. There'll always be that true in a 45 for a right isosceles. Okay. So then, what's the sine of a 45-degree angle? This one you might want to pay special attention to. What's the sine of a 45-degree angle?
1 over radical 2.
1 over radical 2. Now the problem with that is we don't like the way it's written. I actually could go into a math history lesson of why we don't like 1 over radical 2. Basically it comes down, yes?
Should we write this down?
You want to know this one, yes. Yeah, you'll want to know this working here, because it's going to be a little trick we have to do. So real quickly in math history, they used to, what is radical 2? What type of number? What'd you say? It's not imaginary.
Logical,
It's not a prime.
irrational.
It's definitely irrational,
That one.
because you can't write it as a decimal, or you can't write it as a fraction. It's 1.41, it goes on forever, it doesn't end. So the question is, how do I divide by an irrational number? Well, the answer is you can't unless you have a calculator. So prior to us having calculators, which believe it or not, okay, when I first started in math in school, I didn't even have a scientific calculator. We had 4 function calculators. So the generation before me didn't have calculators. So they couldn't have done this they couldn't have done it at all. So what we did was we decided, okay, we don't want to have a irrational number in the denominator. Only rational numbers belong in the denominator. Okay? So it's way back when, history. Anymore, we're not worried about it because we have calculators. But you can't write it with the irrational in the denominator. So all I'm going to do is I'm going to multiply by whatever this is, I'm going to multiply by it again, square root of 2. Because what is square root of 2 times the square root of 2? 2. But if I do it to the bottom, what do I also have to do? Do the top. So I'm going to end up with radical 2 over 2, and that's sine of 45. So sine of 45 is going to be radical 2 over 2. You'll come across that a few times when we have the denominator a radical. You simply have to multiply and rationalize it. Okay? What is the cosine of 45?
Radical 2 over
The same thing.
It's the cosine is the sine of its complement. The complement of 45 happens to be 45. Therefore, they are the same. Radical 2 over 2. I mean, you have opposite over hypotenuse and you have adjacent over hypotenuse, and those two are the same. You have the same trig function. So you have radical 2 over 2. All right, this last one up here, we know it to be, let me go back to red. We know this is to be 90 degrees. What's 90 degrees in a radians?
Pi over 2.
Pi over 2. And what's my ordered pair right here?
0, 1.
0, 1. And there's the first quadrant of the unit circle. Now, if you know this, if you know the first quadrant, you know all 4 of them. You know all 4 of them.
Is it the same?
3, 2, 1.
One slight change we have to do with sines. Like for instance, this is also a 60-degree angle here. So it's going to be 100, whoops. It's going to be 120 but it's still 60 degrees here. So it's going to be the same as this one. So it's going to be 1 over 2, radical 3 over 2. However, x goes this way, right? Which means x is,
Negative. That's it.
and you just follow it all the way around. Follow the same logic all the way around. In this quadrant down here, you're going to come, x is going to come this way, y is going to go this way.
So they're both negative. So y is negative.
They're both negative. This one, x is going to be positive, y is going to be,
Negative.
so positive, negative. but the values are gonna be identical. And we'll fill out the rest of the unit circle at some point, but right now, I just want you to kind of focus, make sure you know those values. And there's lots of ways to memorize it. I've seen lots of cool ways, and you don't really have to memorize the whole thing, just kind of get the first one if you can get the pattern to it. I mean, I saw one video, you have your hand, 1, 2, 3, 4, 5, something like that. 1, 2, 3, like that. Well, there's 90, there's 0 degrees, right? There's 90. So you have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Well, we don't need to run these are 1 and 1. If you put all these over 2, that's a 3 by the way. I did it backwards. Anyway, there's a quick way to do it there. Video or watch a YouTube video on how to make your hand a unit circle. I obviously didn't watch it all, but you can see here, 0, 1, 2, 3, 1, 0, 1, 2, 3. So there's some patterns there you can find. But I would just go back to the 30, 60, 90. Okay, so the unit circle. So, should we dare do this before?
What?
We should dare. We'll do one now, and then we'll come back and do one after lunch. Okay, so you have the first quadrant in front of you, right?
Yes.
All right, here we go. I would say this is an example under unit circle. I would like you to take the sine of, and let's pick a degree. Let's pick pi over 6. Okay? And I'd like for you to find every trig function of pi over 6. Calculate the sine, the cosine are from the unit circle, so you've got those. But then find the cosecant, the secant, tangent, and cotangent. Of all 6 of them. Okay. All right, let me walk you through this one. When we come back from lunch, you can do it on your own. What is the sine of pi over 6?
Radical 3 over 2. No,
Sine of pi.
it's not that.
1 half.
Yeah.
Sine is the y value. Pi over 6.
Oh, I had mine switched around.
Sine pi over 6 is 1 half. Sine is the y value.
Oh, pi over 6. Sorry, I was doing pi over 3.
Oh, pi over 6, so 1 half. Okay? So then what's the cosecant?
Radical 3 over 2.
Oh, the
Cosecant.
cosecant. 2 over 1.
Oh.
2 over 1, or you could just say 2. All right, what's the cosine of pi over 6? That's what you said a second ago.
Yeah.
Radical 3 over 2.
All right, what's the secant?
2 over radical 3.
All right, we have a problem. I have a radical in the denominator. So what do I do?
Why? Find the radical.
Wouldn't it be 2 radical 3 over 3?
It is. Multiply by radical 3 over radical 3, 2 radical 3 over 3.
Okay.
So if it's 2 radicals, did they just cancel out?
Say it again.
If it's 2 radicals, in a multiplication problem, it just cancels out?
Radical 3 times.
They do, but in this case, I want them there because I gotta get rid of this radical. I gotta get the radical out of the denominator. So that's why I put them there.
So where does that go?
Where does what go?
That problem? The answer. The 2 radical 3 over 3.
That's the secant of pi over 6.
That's it.
That's the answer.
It doesn't go in here.
No, the unit circle is only sine cosines. Okay. We might put tangents on there just for fun, but
Just for
unit
fun.
circle is just sines and cosines. Okay. Now, anyone remember how to find the tangent given the sine and cosine?
That'd be O over A.
What'd you say?
O over A.
O over A, okay.
So
Yeah.
sine is the y value, right?
Sine is the y value, yes.
Cosine is the x value.
Yes.
Okay.
So think about that. What did we say the tangent of theta was in terms of x and y?
X y over x.
X, no. Tangent of theta
Is y.
Y over X.
was y over x, right?
Y over
y over x. So what's y?
One,
It's a
Sine.
sine.
one
One
over.
over, one over, one half,
Okay, well, y is the, what, which one of the functions?
Sine.
sine,
Y is sine.
sine over cosine.
Sine over the x value, which is cosine. So it's simply gonna be the sine, which is, 1/2, divided by the cosine, which is square root of 3 over 2. So you just do sine over cosine.
And that's saying, can you simplify that?
Well, when I simplify this value, how do I simplify it? What
Multiply
happens?
by two?
Well, the 2's cancel. 1 over radical 3.
And then multiply by a radical 3.
Radical 3 over 3.
Right, so it's radical 3 over 3.
So, okay, there.
Radical 3 over 3. Simplifying that.
Do you have to simplify or
Say it again?
do you have to simplify?
You have to simplify.
Okay.
They have in proper form. What's the cotangent of pi over 6?
Cosecant over.
Cosine over some.
We can actually do it quicker than that. That would actually work, but there's a faster way to do it.
Well, you flip the
Maybe switch
Yeah.
around the tangent.
Yeah, just take the reciprocal of the tangent.
Um,
Now, here, if I switch it around, I'm gonna get 3 over radical 3, right?
Yeah.
I don't like that because we have radical on the bottom. But what if I go back here and switch this one around?
Then it's radical 3 over 1.
It's radical 3 over 1. So let's just use that. Let's just make it radical 3. Because we simply take this one and take the reciprocal of it. So it's radical 3 over 1, which is just radical 3.
Nice.
So by given an angle, you should be able to come up with all of the trig values of that particular angle on the screen. Okay, so when we come back from lunch, I'm gonna get back, I'm gonna put it on the board now. If you wanna work on it, come back for lunch, we'll do it, make sure you got it. And then that's pretty much it for the day. So here's one you can work on your own or with someone sitting next to you. Let's see here, let's go with, why don't we just do pi over 6? Let's do pi over 3. Give me all 6 trig functions from pi over 3. And we'll give you the answers when you get back from